Hello, my name is Michael Papp. I'm a rehabilitation engineer with the Alabama Department of Rehabilitation Services, and I'm here today to talk to you about the rehabilitation engineering design process and some design projects that you might want to consider working on. A little bit about myself. I'm a rehab engineer with 23 years experience working with people with disabilities. I got here by originally getting a degree in biomedical engineering. After that, I worked a little bit for a prosthetics research and design company. And then I got a master's degree in rehab engineering. Ended up in Alabama here, and I've been working here ever since. If you have any questions, my contact information is up on the screen, and you'll have an opportunity to write that down again at the end of this presentation. So a little bit about our program first. The Rehab Engineering and Assistive Technology program is part of ADRS, the Alabama Department of Rehab Services, and we're committed to excellence in providing state-of-the-art engineering and assistive technology services to our consumers across the continuum of all ADRS divisions to facilitate the dignity and independence of individuals with disabilities in the community, at home, at work, and at school. We work with consumers to help them find or develop assistive devices that will reduce or remove the barriers presented by disability and improve their quality of life. Some examples of the different types of disabilities our engineers work with include physical disabilities, such as people who use wheelchairs, people with learning disabilities, such as dyslexia or dysgraphia, people with blindness or low vision, people who are deaf or hard of hearing, people with developmental disabilities, and also people with traumatic brain injuries. So the different types of assistive AT services that we provide include evaluations and recommendations for different types of assistive technology. We also help with setting up and configuring AT, as well as providing training. We also do custom design and fabrication as needed, and we can provide technical support on assistive devices for people who are currently enrolled in services. So when we go in to evaluate somebody for assistive technology, what we are going to do is start with identifying the needs and the abilities of the individual. And this is where we actually start our assessment. We meet with the individual, with their caregiver, discuss the tasks that they are attempting to do and that they're having difficulty with, as well as their functional abilities. And this can include their physical abilities, sensory abilities, cognitive abilities, and just general knowledge that they might have that will allow them to interact with different types of technology. At this time, we also want to know what the desired outcome is for them. So for someone who may have lost a limb, they may desire to return to work and continue to operate a machine press. Somebody with dyslexia may desire to go to school and become a lawyer at some point. So we are very interested in where that person wants to go. We also, during this process, will start discussing solutions and some of the features of those solutions, especially for items that we are off the shelf and that we commonly do recommend. So we'll go over that with the individual and then figure out what sort of intervention we're going to provide. And so when we recommend assistive devices or a system for that person to help accommodate them, that's the intervention process. And once that's implemented and we've provided them with training and setup, we'll go back and follow up with them and get feedback as to how their device or their assistive technology system is working and see if we have to go through later and tweak it again. So when we evaluate somebody, there are specific items that we look at. And in the AT world, it's called the HAT model, where we look at the human, the activity, the assistive technology that they're using, and the environment in which that person needs to be able to operate or perform various tasks. So when we meet with an individual or their family and caregivers or teachers, we will discuss what the characteristics are of the individual. We want to know what their functional abilities are. We would like to know what their functional limitations are and discuss those with them. If it's relevant, we'll gather anthropometric data. And what anthropometric data is the science of human measurement of physical body dimensions. That could be how tall someone is, what their eye height is, their arm length, their leg length, the size of various body parts, their weight, their reach, how far they can lean over to be able to grab something. So that's anthropometric data. And we will also assess the knowledge, skills, and abilities of that individual. And so we want to be able to see what they're capable of doing in context with the task that we're trying to accommodate. So when we do the task analysis, the way we basically do this is we break down the task into the essential elements necessary to perform it. And so if you have, say, someone is a telephone operator or a receptionist, we're going to go through and identify the tasks that that individual has to be able to do. They're going to list those out, and then we are going to identify what components of those tasks the people are having difficulty with. We want to know how that task is normally done, and then we might look at ways that it could be done in an alternative way if the individual is having difficulty doing it. So say we're working with somebody who has a very difficult time with gross motor movements where they can't move their arms very easily. That individual might be, say, they were a receptionist and they're expected to answer the phone, but they can't reach over and pick up the phone, which is the typical way a receptionist would do it. At this point, this is when we would start discussing different ways that that person might be able to perform those job tasks. We also assess the environment, and so we would like to know where an individual is actually going to be working. Is it going to be inside or outside? Are they in one office if they're inside? Are they in multiple offices? Do they travel? Is a vehicle part of their work or the tasks that they need to be able to perform? Is it bright? Is it dark? Do we have a lot of moisture, wetness, vibration, heat, dust, various other things that could affect not only a person's health and physical abilities, but any devices or technology that they might be using. So we will look at whatever risk factors they might have to be dealing with. So for example, if someone would be using a cognitive prosthetic device, which is like an app that runs on a tablet, if they're expected to be outside all day, they might have glare issues with the sun, and we're going to have to look for ways to mitigate that sort of thing. And then finally, the final part of the model is the technology. And so we will look at the type of technology that is being used or could be used by the individual to perform that task. We want to identify characteristics of that technology, such as, is it portable? Is it heavy? Does it need electricity? Does it have battery power? Does it break easily? Is it fragile? Issues like that might need to be addressed as well. Is it a high-tech device that's like a computer-based device, or are they able to use a low-tech device like a notebook and pen, for example? So characteristics of technology can be very important when you're considering what someone's needs are and where they need to be able to work. So in our evaluation process, when we first meet with an individual, we're going to meet with the stakeholders, including the person with a disability. If it's employment related, we might meet with their supervisor or coworkers. If it's a student, we might meet with their teachers or teacher's aide. If it's someone who's living at home, we might meet with a caregiver, their spouse or parents, if it's necessary. And we'll identify with those individuals the abilities and limitations of the individual, as well as define the activity that they're trying to perform. If at all possible, we try to observe tasks and activities. If we can't directly observe those tasks, we might try and simulate tasks. So sometimes it's not practical for us to see someone actually doing the work. Sometimes we can't do it. Say we were working with like someone who is a scientist and they're performing experiments. We might not be able to be in the room with them when they're doing that, but we would try to simulate that sort of task when we actually do the assessment. During the evaluation, we evaluate the environment as I mentioned. We will note dimensions and light, heat, moisture, sound, and other hazards that we need to be aware of, and other important factors. Another example of this, say if we are assessing someone's home for modifications to build, say, a wheelchair ramp, we want to make sure that if their property is sloped or they're in a floodplain, we want to try to avoid ending the ramp where it might flood often. So that's the types of things that we might take a look at when we're assessing a situation during the evaluation process. And finally, the last part of our evaluation is to discuss possible ideas for solutions that the individual might have or been thinking about, as well as some ideas that we've come up with. We want this to be an interactive process with the people that we are working with so that they have some input, and they can point out any issues, or they might actually have seen a solution that they think might work for them, and that would be a good starting place in our design process. So when we go to interpret and create a report, what we want to do is list out the characteristics, and this is the very first part of the report. So we're going to talk about the individual's characteristics, the activity and the specifics of the activity that they need to be able to perform, that they're having difficulty with, and we will also list some environmental factors at this point so that anyone who starts reading our interpretation knows what we've looked at and knows what we're dealing with. And it's at this point where when we know what someone's abilities are and what's necessary for them to perform a task, the functional abilities they need to have, we can identify a gap between the functional abilities necessary and the functional abilities that they have, and we can look for technology that's going to fill that gap in. And so we want to be able to find something that's going to increase the functional abilities of the individual. And this is really where we start brainstorming ideas for technology that will bridge the gap for that individual. I mentioned training earlier. Training is a critical component of a lot of assistive technology systems. There are some devices that are simpler, more like an appliance where you can just put it in place and it's going to work for somebody. Say like a larger screen for their computer system. But some technology interventions are very advanced or more difficult to utilize. Things like voice recognition for a computer, especially if the computer is performing advanced functions. Someone who might need to use adaptive math software is going to need a lot of training. Any advanced type of computer device, something like an eye gaze system where you can control a computer just by looking at different parts of the screen. All of these things do require training. And we found if you just put something like this in the field and you haven't considered training and just hand someone an advanced piece of technology without any training considerations, it's likely that they're not going to be successful in using it. So training is a critical component. So some case examples of what we've done in the past. And so the first thing I wanted to show you is an adapted sewing machine. So I was working with a gentleman who had C6, C7 quadriplegia from a motor vehicle accident. That's where his spinal cord was damaged about the cervical vertebrae 6 or cervical vertebrae 7. So it means that he had the ability to move his head, he could move his shoulders, and had some movement of his arms, but he didn't have fine finger control. So, and he didn't have any ability below his chest, so he could not control sitting up. He had no use of his legs or anything. And this gentleman had been a car upholsterer. That was his profession before the accident, and he wanted to return to that. And so using an industrial sewing machine, he was no longer able to do that because it did require the use of your feet and your elbows in order to operate the machine. And so what we ended up doing was taking an industrial sewing machine, and we modified the foot controls and the knee controls, and we added some levers onto the system, so that instead of having to use his legs, he was able to use his elbows to be able to control the clutch on the machine, because this type of machine actually has a clutch on it, as well as the foot, which is what holds the fabric down, the upholstery down to the table. And so he was able to manipulate the machine using his elbows. We had taken away all the necessary foot components for that. Here's another example of an accommodation that we had created. This is what I've dubbed a packing tape table.
Okay, there we go. Go ahead.
And so we had an individual who was working in a shipping receiving department, and he had some vision impairment, and he had a lot of dexterity and coordination issues, and he was having difficulty holding the tape gun so that he could professionally tape the box. When he tried to do it, the tape was kind of all over the place, and we discovered he was having difficulty coordinating the tape gun with both of his hands, because he had to move the box in one direction and the tape gun in the other, one in each hand. And so what we ended up doing was designing this packing tape table here, so that he was able to use both of his hands and move both of his hands in the same direction at the same time in order to tape the boxes. And with his vision impairment too, we had set up a fencing system so that he could set the fence based on the width of the box, and he'd have a straight guide. So all he had to do was move the box over the tape, and it worked pretty well for him. So that's an example of an actual accommodation we did. Some other things we do as engineers, we often have to go in and fix things. And so we do a lot of wheelchair ramps. We do a lot of architectural type design along those lines. And so here's some examples of some bad wheelchair ramps that we've looked at that are falling over. Or the one on the top left, you can see the posts are kind of leaning over to the left side. There's not proper bracing. There's no proper footers on that. So we redesigned that for them so that it would be more stable. The lower left-hand ramp is more of a ski ramp. It's too steep. It doesn't have proper support up underneath it. And so in the upper right side, you can see a properly built ramp. It's at the correct slope with handrails, proper footers, proper bracing. We also designed some custom items. In the middle, at the bottom, is a drink holder for someone that we had built and designed so that they could stay at home. Someone with a high-level quadriplegia, they weren't able to get a drink for themselves because they had no use of their arms or hands at all. And so this is an adapted cup system, so the insulated, that we could put water in there with some ice, and it has a straw system that could be set up for them so that they could just go up and get a drink of water whenever they needed to. We did have to provide training on this one because if that tube was too low compared to the water level in the cup, it would create a siphon, and so once you start sucking water out of it, that water would continue to come until all the water was emptied out. So there was a training component on even a simple little straw device like this, so that someone didn't accidentally create a siphon situation. In the lower right hand corner, that's an example of an portable overhead post lift for somebody. It's a patient lift to help transfer someone in and out of bed or out of a wheelchair or out of a bathtub that can be transported around. Another example of an actual job accommodation. This is a one-handed rubber band jig. We were working with a woman who had had a stroke, and she was an accountant. And the place where she worked, they would pay invoices, and as they paid them, they would all rubber band them together into a stack and then put them into the file. And so putting a rubber band on stacks of paper with one hand was very difficult for her. She wasn't able to do it. So we created this custom little jig so that it would allow her, using one hand, to put a rubber band on a stack of papers. And again, it's a real simple sort of solution that one of our engineers came up with. We also do custom desks and workstations for people. And so here is this is for someone with a very high level quadriplegia. I think he's a C3, C4, which means he does not have any use of his body below his neck. And this workstation was set up. He has a very tall wheelchair, and he often has to have it tilted back because he doesn't have muscles in his trunk to sit upright, so he has to sit tilted back. So this desk was designed so that his chair could sit up underneath it, and that he could also use his computer and do other tasks with a mouth stick. So if he had a stick in his mouth, the tabletop was tall enough for him to be able to manipulate things on the tabletop with his mouth stick. And this is an example of the first thing that we 3D printed for somebody, is we created custom measuring tapes for somebody. And someone with a vision impairment, they needed a very high contrast measuring tape in the metric system, and they needed a way to mark and identify what they were measuring. And so this is a custom metric measuring tape with a slide on it, so that they could put the slide where it needed to be to mark, and then they could pick the measuring tape up and hold it right in front of their face so that they could read where it was, see where it was on the scale. The scale's got different colors on it for different numbers, and so they knew what all those numbers meant, so they could identify what the measurement was pretty quickly. Okay, so with that, those are some examples of some past design projects, some stuff that we have done on a daily basis. But I do have some design projects that you guys might want to consider working on. And so the projects on this list are all things that we will get a periodic request for, but they are things that take longer than we really have time to work on. Typically when we have a referral, we only have a day or two to really work through what that person needs, maybe a week at most if we need to do something customized for them. Anything that takes longer than that, there's not something that we really have time to help them with, but we will put those projects on our design project list so that if you guys have time and are interested, you can work on it. Okay, so the first project that you might want to consider, I believe a group at Hoover High had worked on this last year, but I think it needs some refining, is a self-leveling wheelchair seat. And so for some people with really significant disabilities, such as multiple sclerosis or spinal muscular atrophy, they have to sit in a very precise position in order to operate the joystick on their power wheelchair. And if they tilt a little bit one way or the other too much, or front to back or side to side, they do not have the strength to keep their hand in position, and their hand will fall and they will not be able to control their wheelchair. And so the goal of this project is to have a system set up that will keep their chair level front to back and side to side at the angle that they need it to be at, so that they're able to operate and control their power wheelchair. So that if they're driving, say, down a wheelchair ramp, they don't lose control of their wheelchair because they're on an angle. That the seat will change angle as the angle of the base changes. of their wheelchair. And so an example of the type of wheelchair we're talking about, we're not talking about the consumer grade hover around type wheelchairs. We're talking about something more advanced from what we call a rehab style chair from a company like Invacare or Permobile. These are chairs with really complex seating systems on them. They are designed where there's a base component, and in this picture, the red bottom part is a separate component of the wheelchair, and then there's a bunch of different components that go between the bottom and then the actual seat frame on the top. And so this particular wheelchair has a tilt back function, so it will tilt the chair back, and we call it tilt in space. But it's not automatic, and it doesn't keep the chair level side to side. But this is something that someone with high-level quadriplegia might use. With the chair tilted back, it will help keep them seated properly in their seat. Another interesting project is a portable voice amplifier with frequency shift. And so we do occasionally work with people with very soft voices due to their disability. They might have poor breath support, or their vocal cords may have been damaged, or may have some sort of problem with their vocal cords where they cannot talk. And so we will get those individuals something called a speech amplifier, which is a little box that they can wear with a microphone that they can talk into, and it's a portable public address system essentially. It just amplifies it. But if that problem has if the person has issues not only with their volume but their pitch, such as if they have dysphonia, which is where their vocal cords are extremely tight and they talk in a very, very high-pitched voice, they don't have control over that because of the tension on their vocal cords, or if someone has had a laryngectomy or damage to their vocal box, their pitch of their voice may be very low. And in either case, when their voice is soft and pitched really high or really low, it can be very difficult to understand what somebody is saying. And a typical voice amplifier, while it can amplify their voice a little bit, it doesn't increase the intelligibility of what they're saying, especially if they're in a loud environment or if they're trying to talk on the phone. Because a standard telephone, you'll notice if you talk to somebody on their phone, their voice sounds a little bit different. And that's due to what's called frequency clipping. And so the phone is actually clipping the high and the low frequencies from their voice to reduce the bandwidth. And when that happens, especially for someone whose voice is really high or really low, it's clipping out most of that signal so that you can't understand what they're saying. And so what this project is about is building a voice amplifier that will switch that will have an adjustable frequency where you can change the frequency so that you can actually put the frequency of their voice that's being amplified in a hearable range. So this is a standard voice amplifier. You can find these on Amazon. They're $100, $200 for a decent one. It's just a box with a microphone and a volume control essentially. And so we're looking for a similar device to this, but one that we can also change the person's voice frequency. All right. Hearing aid audiogram sound filter. Okay, so this project is really what I would call an empathy project. And we work with a lot of people who have had hearing loss, and for their loved ones, their employers in some cases, have a difficult time understanding why they can hear some things and why they can't hear other things. And so we'll have situations where an employee's supervisor might get mad at them because the employee can't understand what that supervisor is saying, because their voice is a high pitch or isn't a range that that person can't hear well in, when that person can still hear other employees. And so it's typical. Hearing loss tends to happen at higher frequencies. So people experiencing hearing loss will have more difficulty understanding women with higher pitched voices than men with lower pitched voices. And so this does cause some issues and difficulty. Why someone with hearing loss might not be able to hear a baby crying. And so what the goal of this project is to create a sound filtering app or program or website or box type device where someone can take the results of their hearing aid audiogram, and this is what a hearing aid audiogram looks like for people with different types of hearing issues. But what the audiogram does is that it will go through the different frequencies that someone should be able to hear. So this one starts at 250 hertz and goes up to about 8,000 hertz. This is in the range of normal speech, and it will identify what sound pressure level or how loud a noise has to be at that frequency for the person to be able to hear it. And so for the audiogram in the center, you can see that the person's right ear at 750 hertz, they can hear sound at a very low volume. But in their left ear, it has to be up about 65 decibels for them to be able to hear that sound. And so at 1,000 hertz in their right ear, they can hear about 5 decibels at 1,000 hertz. They can hear that. But for their left ear, it has to be at 70 decibels for them to hear. That's pretty loud. And so that's what a hearing aid audiogram looks like. And so what we would like to be able to do is have them have an app of some sort or a program where they can put the results of their hearing aid audiogram into that app, and then they can play a piece of music or something that they have recorded through, so that a friend or family or employer supervisor can listen to it through some headphones and understand how their hearing loss has affected their ability to hear different sounds, especially at different frequencies. And so this is kind of an empathy sort of device. It would be very helpful for people if they had this on their phone, or if they could pull it up in a web browser and be able to actually just show somebody, like, this is what I actually hear when the baby cries or the doorbell rings, or when you talk to me. This is kind of what it sounds like, filtered back through that audiogram filter. Okay. Captioning telephone for business use. This is another hearing loss project, and so for some people with hearing loss, they cannot use a standard telephone, and they have, for personal use, have the option of getting a phone for free from what's called a relay service that will allow them to speak on the phone and receive captioning. And so when you're talking with someone who has a hearing impairment who uses a relay service, when you call them, you will actually get an operator at the relay service, and you talk to the operator, and the operator will type out what you say for the person with the hearing impairment. And they have a special phone called a CapTel phone, and this is what it looks like. And so when you're talking to them, they will be able to read what you're saying. And if they're late deafened, which means they've lost their hearing after they learned to talk, they can talk to you back on the phone. If they're completely deaf, they might be using a TTY to communicate back to the relay operator, and the relay operator will talk to you. So there is a free version for people who are at home, but there is not a version that will work with business systems like PBX or voice over IP type systems And so they are looking for, and this is from our deaf service program, they're looking for solutions where people might be able to use a captioning phone on a digital system instead of the traditional analog home phone systems that so many people still use in their houses. Okay. Another project, floor transfer device. And so this was brought to me by a local gentleman who has paraplegia. He uses a wheelchair for his mobility. He likes to work in his workshop and get up and on off the floor. He also travels a lot, and he needs a portable lift for traveling. And so what he is looking for is a floor transfer device that can help lift a person off of the floor to a wheelchair and vice versa, that will be more portable than the traditional type patient lifts, like a Hoyer lift, if you look that up, or look up patient lift on Google. You'll see what I'm talking about. These are large lifts. It looks kind of like an engine crane for lifting a person up. And so he's looking for something that's going to be smaller and easier to use, something he can use in his workshop around the house when he's doing repair work. If he's got to get down and get up under the sink, he's got to have a way to get up and down easily, or when he's traveling. And so, yeah, here actually is a picture of a traditional patient lift. This is a fairly large item. It weighs a couple 100 pounds. They're large, they're hard to move, they don't fit through doorways. I also have an example of a creeper, or an adjustable creeper, which is the sort of device that might be modified to perform this type of task, where it'll be down on ground level, but could also be adjusted to lift up to, say, the height of a seat or a bed, say 20 to 25 inches in height. So that if it was down on the floor, potentially something like this might be, a similar design might be used to make this type of lift system. Power wheelchair training device. Okay, so this is another, this is a great project from our children's rehab program. A lot of children who are very, very young, there's been a lot of studies that have shown that the ability to move oneself and navigate in one's own environment is very critical for neurological development. And so for very young children with severe disabilities, therapists are very interested in getting them into powered mobility, so that they can move themselves around if they can't crawl or walk by themselves, because it does help improve their neurological development. And so one of the issues that therapists run into with getting insurance or Medicaid to pay for powered mobility is often they want proof that the child, and we're talking about children who are 18 months, 2 years old, 3 years old, very young children, the insurance really would like to see proof that they are capable of moving and navigating the chair by themselves. And so this is the photo on the right side of the screen is of a child's pediatric power wheelchair. And so this is a pretty advanced type system. It's got a very rehab style seating system. It's got a custom joystick and all that. But what the therapists are looking for is a power wheelchair training device where the patient can be seated in their traditional manual wheelchair or a rehab style stroller. They're looking for a platform that they can put that chair on that has the ability, that has motors and has a joystick, where the child can actually be seated in their own system and they can practice driving around and learn from the therapist how to operate a power wheelchair, so that the therapist can actually go ahead and recommend one for them and get something like that from insurance. Okay. All right, Vibrating Pen. I think your teacher had reached out to me about this one because there was a group that worked on this last year. But There has been some research that has shown that for people who have tremors, especially Parkinson's tremor, having a pen that vibrates can help them write more clearly. And so we are looking for a design for a vibrating pen with replaceable ink cartridges that's rechargeable and easy to use. The group last year did a pretty good job on this. There's some improvements that could be made. One of the things that we're looking for is, well, first let me show you what I'm talking about. Here's some writing examples from people with Parkinson's and essential tremor. And so with Parkinson's disease, people will have what's called micrographia, where they write very, very small, or they have a lot of difficulty just writing clearly. And some research studies have shown that having a pen that vibrates affects their motor system in such a way that they're actually able to write more clearly with something that is vibrating versus something that is not. There hasn't been anything definitive on the frequency of the vibration or how intense the vibration needs to be. And so we're looking to work on this project a little more, where we can have a vibrating pen where we have the ability to vary the frequency and vary the intensity of the vibration, so that we can try it with different people and see, is there something that's consistent, a particular frequency that seems to be better, or does everyone just seem to need a slightly different frequency? And so that is what the Vibrating Pen project is about. Okay. Here's another project, a new one, is a screen door operator. And so for our people living at home, especially who are in wheelchairs, we do recommend automatic screen door openers, and those are great for opening the exterior door. They cost $1,500 or more for a decent one. And what these are is there's a module in the image on the upper left part of your screen, the upper left image, I guess, is an example of a door opener. It attaches to an exterior door, has a little remote control, some circuitry, there's a battery in there, and there's a remote that the person might have on their wheelchair. And then the other thing that they will have for an exterior door, the image on the left bottom side is an electric door strike, which is installed in the door as well. And so their door can be secured, and when they hit the door opener, the door strike will allow their deadbolt to open, and that they can then open their door with the automatic door opener. Unfortunately, if the person has a screen door or security door or storm door, this system doesn't work for them. We would have to get 2 door openers and find funding for that for the individual. And so what this project is aiming to do is to somehow create a leverage system so that when their interior door opener is working and operates and opens the door, that it will also be able to open the screen door for them, so that that screen door will open as well. It would be good also if there's a setting where you could open the interior door but not have the screen door open, because the point of having a screen door or a storm door is that you can have your inside door open without opening the screen door. But right now, the only thing we can really do is remove someone's screen door if we have to put a door opener in. So this project is looking for some sort of system, a lever system or something that will allow them to open the screen door when they open the interior door. Okay. I think we're getting down to the last of them. So movement reminder. We do work with a lot of people with very significant developmental disabilities, and they work in what's called supported employment. And this is where a job coach is working with the individual. And so a job coach is there to provide extra training and support while someone is learning to do a job. And as they master that job, the job coach will kind of phase out. So it's not a permanent thing. And we are having an issue every once in a while where somebody that we're working with will enter what I call a task stupor, where they just stop working until they're verbally prompted to continue. And so one example, I was working with a young man at a church whose job it was to go through and make sure that each seat in the pews had a hymnal and a pledge card and a pen and some other paperwork. Maybe the church bulletin, for example. And so he was doing this as a part-time job, and he would get going and be doing okay, and then he would just stop working until someone told him to continue. And so if there wasn't a job coach or a supervisor or someone in the room to see that he stopped, all he needed was a verbal prompt to say, "Hey John, keep working," in the voice of someone he trusted, and he would continue to do so. And so what this project is looking at, a lot of people have seen a Fitbit or a smartwatch where they will remind you to get up if you've been sitting too long at the computer, like 2 hours. And what we're looking for is a reminding system, and this could be an app that just uses existing hardware that will remind somebody in the voice of someone that they trust if they stop moving, stop working, doing what they're supposed to do. It will just give them a verbal prompt to remind them to continue to work. And so we're just looking for some sort of automatic system so that when we have someone who is experiencing problems with this, that we don't have to have someone in the room watching them constantly. I mentioned a thing like a Fitbit with a smartphone app. That's one possible solution, like a wearable type device. This could also be like a webcam system set up in the room as well. So there might be a variety of different ways to do this for somebody, but we are looking for an automatic way where we don't have to have someone, a human being, prompt that person to get back to work continuously. All right. So some similar products that we've used. The watch binder has been around for a long time. That's the item on the left. We've used that for a lot of people. It does not have a verbal prompt. It also doesn't keep track of motion. There's a time timer, is another type of device that we've used sometimes with supported employment that converts time into more of a volumetric, into the pie shape, so that people understand, so that it's easier to understand if you only have a little bit of time left versus a lot of time left. And then we've also used various smartphone apps like the Endeavor system on the smartphone on the right side of the screen. So we have used products to help support people in supported employment. We just haven't found anything that quite does what this project is looking for. Okay, so there's a whole list of projects. If you guys are interested in any of these projects, please let me know. My contact information is up on the screen. It's michael.papp@rehab.alabama.gov is probably the best way to reach me. My Birmingham office number is 205-290-4460. Feel free to reach out to me if you have any questions. Okay? I hope you all have a great day. Bye.